And to understand and repair air conditioning electrical wiring and components, in reality, it's very easy. You'll find it's super simple. It's all really the same. If you know how to use a meter and trace out wiring, it'll be pretty simple. But all you need is you need an understanding of how parts work. So you have to know what the parts do and what they are, how they work, what makes them turn off and on in order for you to troubleshoot them. If you know what something does, then you can always see if it's doing it or not. It's very simple. You also need to know something's sequence of operation. And if you know those two things, you should be pretty good tech as far as understanding the electrical. And so to understand how parts work, let's start here. We have, as you can see, a bunch of air conditioning parts, heating parts, and essentially wanted to talk about relays because these are pretty much all your air conditioning parts. Right here, outside of your big parts, which are your compressors and your motors, these are most of your little things. And I'm not going to cover every last single part in existence. We're going to cover the major, most common ones and help you understand electrical and how different parts are in reality the same thing. And so we'll talk about relays. Relays. These are all relays. That's all they are. Now, they open and close. Even this is essentially, well, it's a safety, but it works something like a relay. And I'll explain. And so, this is a contactor. This is a relay. But they both do the exact same thing. They open and they close. And so if you have power coming in to this from your breaker and it's open, your compressor and your contactor are all wired here, but as soon as this closes, power is bridged across and sending power to all of your parts. Therefore, closed means bridging power across. And so this and this do the same thing. You would have power going in, and this would go to your parts, whatever you had this wired off of. And these are both controlled. What differentiates these type of relays is what tells them to open or close. So this contactor is told to open by getting a signal of 24 volts to the coil here, which will then close the contactor, sending power to your components. The relay would in fact do the exact same thing. If you read it here, you could see that the coil is 1 and 3 here and here, and so if you were to give 24 volts to this coil and you had power here, it's normally open, and so this terminal and this terminal are normally open, meaning they're not connected with continuity. But if you give this 24 volts, they become normally closed, and so they connect, becoming normally closed, sending power to the other side, just like this. And so this is also a relay, just the same thing. It just looks a little different. They like to confuse you, but originally this is just another relay. So these here, just simply the very bottom two, A and B down here, are your coil, 24 volt coil. And just like this relay, this does the same thing, except this is just 3 different relays is all this is. You could put power here, 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 or here, and this is normally closed to there, and to there. So these are closed, these are closed, these are closed. But if you give it power, this will now de-energize here and switch up to here. Same for all 3, so you have 3 different circuits. So you just have to understand what a part is and what it does in order to troubleshoot. So here we have another relay. It just handles more duty, and that's the difference between these 3. Light duty, medium duty, heavy duty contactor. So the more amps you're going to be pulling, the heavier duty relay you're going to use. And so it's a contactor, it's a relay, but they do the same thing. Now here, we have a time delay relay. And so if you got power going in here, and you got, say, your blower motor coming off this way area, this terminal, and you energize 24 volts here, it's going to time delay, and so it's not going to come on for a few seconds. It's going to time delay before bringing it on. And so if you were to troubleshoot that, you would give it power, see if it closes after its time delay. Same here. We have another time delay relay, a double stack sequencer. And so you give 24 volts to the bottom here, and the disk starts warming, and after a second, this one will close to here, so that one will close to there, and then after another second, that one will close to there. Purpose would be, maybe you could send your, if you were working on a straight cool with strips unit, and you wanted the heat to come on, you would energize, you would send common to one side, and you have the energized from white, and you would send power here and here, and this one would then bring on your heat strips, and then this one would bring on your blower motor. So your heat strips would come on, and then just seconds later your blower motor would come on after giving them a chance to warm up. That's what that's generally used for. But so you got to just understand what parts are in order to fix them. This open and closes also. It's really anything ever does is open and closes. It's just some open and close due to getting voltage, like all these, and some, like this one, open and close due to temperature. And so when this senses that it's too hot, this will now open. So it's a safety switch, but in reality, it's just a relay that opens and closes from a different type of signal. It opens and closes due to heat. Here, we have another. This is a pressure switch, but it's just a relay, guys. It's just opens and closes, but this one opens and closes according to pressure. So just like the rest of them, it'll open and close. You know how to test this. You know how to test all these things, because all they do is open and close. You get a meter, you put it on continuity, see if they open and close, or you just get your meter on voltage, and you know, if you have your meter here, and you have voltage, and it doesn't have voltage here, then you know it's open. And if you suck on the tube here, I'm sure you heard that. I heard it close. I'm sure if I had a meter on there, it would have all of a sudden started beeping because I would have had continuity. Just closes from a different signal. Instead of voltage, it closes off pressure. And, you know, moving on, we have a emission module, or circuit boards would be the same thing, but these are just a series of relays. It's just on the board, a whole bunch of them. And so if you were to, for instance, give this thing power, GH, 24 volts, and you're essentially giving this thing power, and so it's going to respond to your 24 volts. You have to know its sequence of operation now, because I would know that it would start sparking, and then it would energize the pilot valve. You just have to know how something's going to work. Here we have a transformer. So it's not quite a relay now. We have something different, but you got to know what it does in order to troubleshoot it. Once again, you got to understand how parts work. This gets voltage and transforms it because it's a transformer. So you just wire the voltage going in, and the output's going to be 24 volts. And so if you have high volt going in, you have 24 volts coming out. You got to make sure you're wiring on the right wires, though. And so if you're going outside at the condenser, you're going to probably go white and orange, which you very rarely going to do that. So more than likely, you're going to go white and black in the furnace, and then send that to your board for your 24 volts. And so outside of that, we have other parts that are very important. We have compressors, and I know I don't have to show you guys what those look like. Oh, we have motors. Well, let me go out here, show you guys. So you have your motor, and you have your compressor in there. And so, and you have a capacitor. Outside of that, there's nothing else to it. Contactor, compressor, condenser motor. So, and in here you got the blower motor, of course. So we're talking about air conditioning right now, and so I'm not going to go into heating too much. But here we are. I've kind of went through how parts work, and so now that you understand that just things can open and close, one voltage controls another, essentially, guys, all we need to do in order to make this air conditioner, or this virtual air conditioner we got here, turn on, is we got to give all the major components power. I mean, it's as an air conditioner, essentially. We have a thermostat, we have a transformer, we have a heavy-duty relay, we have a blower motor and its capacitor, we have a contactor, we have a compressor and its capacitor, we have a condenser motor and its capacitor. And, you know, we all know the coil's going to be here, guys, and so it's going to blow through it, but there's nothing to do for you there, so we're not going to talk about it. This is essentially an air conditioner. Air conditioner from scratch. Now that we know what air conditioning parts do, let's wire it from scratch, because if you can wire it from scratch, you can fix them or trace them out. And sometimes when you run into an old obsolete unit, it doesn't matter that you can't get the part, because you can grab all the wires, throw them on the ground, and leave yourself a compressor, a motor, and a motor, and I guarantee you can turn it on and blow cold. Now, if it's a super high efficiency unit, you're going to need some specialty stuff, 2 stages and whatnot, but we're talking about the most basic of units here, because we're talking about basic electrical understanding. And from here, once you understand it, even if the parts aren't really what we went over, a different type of part, it's the same thing. It opens and it closes. So if you know what's telling it to open or close, then you can diagnose it. So let's start. Let's wire this air conditioner. We're going to start by at the indoor unit, and we're going to start by giving our transformer high volt so we can get our low voltage. We need our low voltage to control things, and then we'll give things high volt. And so on our low volt here, let's get a transformer. You can see the 4 wires, and so I got 115 volts coming in. So I want to wire this transformer with black and white. So we got orange here. I'm going to cap off orange. I'm going to cap off red. But I'm going to send black and white to high volt directly. I'm just going to bridge them. There it is, guys. See it? High volt in. And you got your yellow and your blue coming out for your low volt. So this is the most basic of systems. So all I got is a blower relay. In most cases, you're going to have a circuit board, and we could go into heating, but this is just to understand how to turn on an air conditioning. And some older units, we're just relying on blower relays. And so in this situation, we're going to make this one common, this one yellow. We're going to bring common down. And then I'm going to give it a junction, because I'm going to have to send it over here to the coil of the contactor. And I'm also going to have to send it over here to the coil of the fan relay. Okay. Now this will typically be done through your thermostat wire, but for this sake, we're just going to draw it in. So common, there it is, there it is. That's it. We don't need common anywhere else. I'm not going to give it to the thermostat, because I don't want to give them an opportunity to blow their own transformer and make me come change it. Yeah, let's give it common just for, okay, there it is. And so those things aren't going to turn on yet, but as you can see, they have one side of power. We have 115 coming in, it's being flipped to 24, and so this thing requires 24 volts to turn on, like we discussed. Requires 24 volts. We're giving it common through this one. But now, when we want the fan to turn on, we need this thing to close. So what we're going to do is the other side of 24, we're going to bring it over, we're going to jump it, and it goes to right at the thermostat. So transformer, common, send common everywhere. Everything that needs common, just give it to it. That thing needs common, it needs 24. Your contactor needs 24 volts to close, so we're going to give it 24, or half of 24. Now, when you have a demand for cool, you flip the thermostat to cool, set it to auto, and 60 degrees, just so we know it would turn on. What would happen now is it would now connect red to yellow and red to green. And so we'd be closed. It's essentially just another relay. It's closing. When we put it in demand, it closes red to yellow, and so now yellow is going to now be continuing this other line of 24 down, and it's going to go to your contactor, which would now close your contactor. So if you had high volt coming in, you would now energize high volt to your parts. So let's continue on. We would also be giving power out green, as I said, remember? Jump it, jump it. And that would want to come down here, and that would be closing your fan relay. And so if you had a line of power coming in here, it would now bridge to here, which we know we would send that to our blower motor. So on this most basic of units, our low volt is done. If we had heating, if we were going to do heating, which we don't have a lot of room on this diagram, we would simply put this thing into heat, and now it would send the red wire to white, and it would go now and control your heating relays that would work the exact same way. Different relays, opening and closing. So now that our low volt is done, let's do our high volt. You have 208, 230 coming in. So we would want to simply bring that right to our contactor. So our contactor is now energized. So when the thermostat goes into cool, it's going to send this 240 volts that we just got it wherever we send it. And so let's send it somewhere. Let's wire up here. Let's send our 24 volts to our condenser motor. That one just wants to go straight to it. It wants 230 volts to turn on. It also has two more wires that are brown for the capacitor. So those you just want to connect straight. Very basic and easy. Now this thing, when this is open, it's going to be off. When it closes, it's going to be on. What closes it? Well, yellow does, because it's already got common at all times. So all you got to do is close the thermostat, or turn the thermostat on. It will close red and yellow. Close your contactor, turning on your condenser motor. Now, but you're not done. You won't have cool yet. You got to have a compressor that comes on. And so your compressor only needs common, run, and start. So let's give those things what they want. So common, we're going to run it over, up, and a little far. Bridge off of here. Common. So common. We're giving it this side. We're giving it T2. Now it also wants the other side of power, but it wants to share that through the capacitor. So run also is the other side of power. But now run also needs to run with a capacitor. So just tie it off. Pretty simple. Now don't get tied up on where this connects, because you could have taken this over and connected it there. It wouldn't matter. We want to bring start from the compressor over here and give it the other side of the capacitor by itself. And there we go. So now when the thermostat is turned on in demand, since the coil already has one side of 24 volts straight from the transformer, it'll take the other side of the transformer and send it down yellow to the contactor here, closing it, in fact giving high voltage now to our compressor and our condenser motor, and so our condenser will be on and operating properly as long as it's charged right. So now the only thing we're lacking is a blower motor. We gotta have airflow in order for the stuff to work. So, gotta have airflow. We already brought this coil on with our low volt, so let's just simply wire our blower motor. We know it's gonna need a capacitor into the two brown wires of the blower motor. Now we got our speeds here. It's a 3-speed motor. We got white, usually common. We're going to give that straight to one side. If there was a board, I would send it to the board, but since we're doing a basic one, I'm just going to give common 115 volts. Because guys, don't get caught up on how I'm wiring it, because what I'm trying to help you understand here is what parts need. And so what I mean is, you could give this thing needs high volt to turn on. And so we got to give it to it. It doesn't matter where you get it or how you get it, because a lot of brands and types are going to get it from different spots or different places. One might get it by just wire netting it. One might get it by going to a circuit board that has the high volt coming in, and then you, in fact, have your terminals going out to here. But in fact, you need to know what it needs in order for you to test for it. And so it needs white, common, one-sided power. And now, since this is just a simple basic 1-speed unit, we're going to go ahead and choose medium speed, blue here, to use. And so we're going to give blue, bam, right to the fan relay, the normally open terminal. Because when I energize it, it's going to close, and so it's going to energize. And so we're going to cap these ones off. And so now this one, of course, needs to get power from that side. And so now our blower motor will get both sides of power when it turns on, because it's getting one side all the time, and the other side it'll get from this fan relay when the thermostat is turned on into cool. Because a thermostat in the cooling mode has yellow and green jumpered inside for a single stage unit. And that's it. That's electrical. Parts are pretty simple. One voltage controls the other, as I think Talon said. You can see the low volt controls the high volt. You have to transform high volt into low volt, and then simply give all your parts what they need. And so, you know a contactor needs 24 volts to close. Give it to it. How are you going to give it to it? It's from the transformer. Now, don't get caught up if it's going through a board or through some time delay, because essentially that's where it's going, and that's what that needs to turn on. So that's a real basic understanding of an electrical system in an air conditioner, how it works. On old units, when you can't get circuit boards, it's okay to rip all the wires out, throw them on the ground, and put some parts back and wire it like this. I mean, if you can do that, you could turn on an old unit. I don't think I've ever quite ripped out boards and gone in with just one fan relay, but I have added a fan relay. You got to know how they work. You got to know the sequence of operation. And so now we've just wired one. Let's go look at a air conditioner here. So sequence of operation, you know, you got to know the sequence of operation of something in order to diagnose it. And so the sequence of operation in this system here, a straight cool unit, condenser, and furnace, is that we'll come to the thermostat here, and we'll turn it on. Cool, auto, and 60 degrees. And so what's going to happen next? Sequence operation. The blower motor is going to turn on, and this is going to turn on, the compressor and the condenser. But what's going to happen really is we're going to turn on, it's going to close, connecting red and yellow, which are through this thermostat wire, getting 24 volts, I'm sorry, one side of 24, but it's going to send it out to the condenser, closing the contactor and turning it on. Let's talk about heating real quick, because the electrical has to do with heating too. And in heating, you really have a circuit board that's generally doing everything for you. And so this is where knowing the sequence operation really comes in, because on most furnaces, you just have to simply, let's say this thing was broken and we wanted to fix it. We would simply turn the thermostat on to heat auto 90 so it would stay on, and we'd sit here and we'd watch it. And what we should see first is this inducer motor should come on and remove all the toxic gases and blow them out to flue. So that happens first. Once that happens, I know the next thing in sequence of operation is that the pressure switch here is going to sense the pressure being pulled through the tube from the inducer motor being on. And what it's going to do is it's the relay, like we said, so it's going to close. And so one side here is going to be energized at all times, and when the pressure switch closes, it's going to send that power back through this wire down here to the circuit board. And that's going to tell the circuit board, yep, the pressure switch is closed. That means the inducer motor's on. That means it's safe to light the gas. And so next thing in our sequence of operation is going to be the glow igniter is going to start glowing, or the sparker might spark. If it's a glow ignition, the glow ignition is going to glow. It's going to get bright red, and just when you think it's starting to go out, the gas is going to open. It's timed just right. Boom, gas ignites. It should ignite immediately. And then this flame sensor here is going to sense that heat from the flame and turn it into millivolts, sending it back down this wire to our board, telling it the flame is lit, we have ignition, and so it's okay to continue letting out gas and continue heating. Then this one is wired where the blower motor will come on maybe 60 seconds later. After it gives a chance to warm the heat exchanger up, the blower motor should come on off the board, the fan relay. And so you have to know the sequence operation, because all I would do now is I would watch this furnace and know the sequence. If at any point I had a pause, let's say I had the inducer come on and then nothing else happened, I would start questioning the next step. I would say, well, did this sense that this opened or not? And so I would pretty much test to see if this thing was closed. If it was closed, I would move down to here and look at the board. I'd say, well, the pressure switch is closed, it's sending power back. I'd test the signal. I'd say, yep, the board should be knowing that the pressure switch is open. Why ain't it bringing on the hot surface igniter? And so I'd come look at the hot surface igniter and maybe test its continuity. If it was bad, that'd be my answer. I would say, well, in fact, the board was sending power. You could even come to the clip and test power coming out of the board to the hot surface igniter, and you see if you have power. If you have power going to it and it's not glowing, it's bad. If there's no power going to it and this thing is closed, then your board's bad. Because you knew your sequence of operation, you could tell where it's failing in its step. So you have to know a sequence of operation and what parts do. If I didn't know that this pressure switch closed off a pressure, how could I diagnose it? If I didn't know that that came on first and this closes second, we spark or glow third, I wouldn't be able to fix it. So, and then also once it does ignite, let's say it ignites and everything's good. We're heating. Why are we here? It's heating just fine. Well, maybe there's going to be a safety or a limit that goes off. And so if the heat turns off for a second, you go through with your meter now looking for voltage, looking at this limit here. Find the limit that opened. Why did the heat go off? And if a limit opened, then you have to wonder, did the limit open because it was supposed to? Or did it open because it was doing its job, and maybe the coil's dirty, and there's no airflow, therefore the limit did open for a reason. So you just got to know your sequence of operation, and you can fix it. Hope that helps. That's electrical. Oh, I gotta show you guys this. If you watch this whole video, then you're in for a treat, because I'm gonna show you guys how to stream live from the attic. I've made this, and so here's what it is. That's